Hopefully I can open. I can't. Let me see if I can open here. Wait, hold on a second. Let me see. Circle. Open in good notes. Import new document. Okay, great. Okay. All right. So the reason why I need you guys to know is there's different things happen here. You should know this already if you go through my classes, but I'm gonna go through it with you again. I already told you I don't like those finger trick from the TikTok using those 3 finger. I don't know, you know what I'm talking about. I don't like those tricks. I like to actually the material. So let's go through them. Let's just start with the angles. The angle is, I'm going to start with a black. So that's going to be 0. It's going to be 180. This is going to be 360. And this is going to be 90. And this 270. This one should be pretty easy, standardize everything, right? Okay, halfway, I'm going to say it's a blue. So it's 45, 135, 225, and 315. And that's all the blue. Now, why is they all blue? Because all those angles have the same reference angle. It's 45 degrees. You guys know what's a reference angle, right? What is a reference angle? The angles to the closest x-axis. So you think about 225, the angles to the closest x-axis, that's still 45. So all the blue angle is still represents things. Can you guys see or no? Hopefully that's better. If not, then just move forward. You should know your trig stuff. And then I'm gonna go with the red. So the red is 30, 150, 210, and 330. Is that okay? That's all the red. And I'm gonna pick another color. What's a good color? Green. Green is 60, 120, and 240, and 300. And that's all the degrees. So degree has 3 different colors, and the black one is all the main axis. So hopefully you know that. Once you get after that, it's gonna go into the radians. So radian, I'm gonna start with the black. This is 0. This whole circle is what? 2 pi, and the half circle is what? Pi. And what's a quarter circle? Pi over what? 2. Okay. And this one is 3 pi over 2. Okay, so hopefully you guys know that. If you know that, great. If you don't know that, now you know it. Now, what I liked about this pi is this. This could be 2 pi over 2, or 3 pi over 3, or 8. So it's a 4 pi over 4, and this is 6 pi over 6. So it can be used as a lot of time as a reference to see where the location is. If you see that as a pi, it could be 2 pi over 2, or 3 pi over 3, or 4 pi over 4, or 6 pi over 6. It's very easy to generate other values. So if you're able to generate other value, it's going to be easy for you to figure out things. Are we okay here? Okay, 45 degrees. What's 45 degrees? What is degrees? What is the radian for? Oh, by the way, do you guys know radian? What's 1 radian mean? No. 50 what? You're pretty close. 57.3 degrees. 1 radian is 57.3 degrees. 57.3 degrees. So that's just 1 radian is. But if you don't know it, well, now you know. So here it's gonna be pi over 4. Now, why do I know this side very easily? Well, I know that is same opening, right? So I can track back from 4 pi over 4. So that's gonna get down to 3 pi over 3. So that's gonna be 3 pi over 3, 3 pi over 4, sorry. 3 pi over 4. And that because you track it backward. This is opening is pi over 4, you subtract it. And then you can add it to the other side. That makes this one as a 5 pi over 4. Brandon, can you see? Okay. Now, when you get to here, Brandon, what will it be here in this angle? Right here, I circle over there on the right bottom corner, around 430. This one here. What do you think that radian is going to be? Good. How do you know that's 7 pi over 4? Very good. That's very good. So all you guys need to know this. So hold on. Let me erase it. So that is going to be like this. This is going to be 7 pi over 4. So now you know all the blue. Again, blue is all reference angle to each other. So you need to know the reference angle. Another 30 degrees. So I'm going to go 30 degrees here. So it's going to be pi over 6. And Sam, what's going to be here on this side? Good job. So 5 pi over 6. And 7 pi over 6. And Devin, what's going to be here? Excellent. So, oops, I just erased all the stuff. 11 pi over 6. Okay, so that's going to say 11 pi over 6. So now you know all the red. Now I'm going to get this down out of green. So this is pi over 3. This is 2 pi over 3. This is 4 pi over 3. This is 5 pi over 3. And yep, now I'll get down to this part. So this part is all easy. Everybody should know this. Everybody's no problem, right? Charlie, this is all no problem. Okay. So now the last part is you guys need to know where the angle come from. So it's 0. So right here is going to be, they are just regular coordinates. So it's going to be 1. Sorry, that's going to be black. This is going to be 1, 0, 0, 1, -1, 0, 0, -1. And if you know that. Okay, so last one is you're going to see there's a triangle. So I'm going to use this. Hopefully, oh, no. That's not a color one. Blue. They don't have blue. Why they don't have blue? I'm mad they don't have blue, but I'm going to use the closest thing to blue. That's not blue.
What is it?
I don't know, but that's like an Among Us color. It's cyan, right? It's cyan from it's cyan from Among Us. I played Among Us before, okay? Huh? I'm pretty good at murdering people behind them. Yes.
We gotta play Among Us.
We can do it on Zoom. It would be actually more fun. Okay, so besides that, you guys all know this value, but do you know why that value is that way? This value, you guys all know that's what value is that? No, the coordinates. Huh? Yeah, why that is. Why that's a square root 2 over 2. Do you know that? Okay, so you're right. It's that way. So remember, you have to know in geometry. The reason why I'm helping you this right now is because you should see this on SAT a lot. It's called 45, 45, 90. So if this is congruent, this is congruent, this is 90 degree, that's a 45, 45, 90, and this is on SAT. This is a 1, this is a 1, this is square root 2x. Well, actually, this is x, and this is x, this is x square root 2. It's on first page of SAT. And this is a 45, 45. Does that make sense? Mm-hmm. If you have the triangle like this, and remember that the hypotenuse here is what? Inside unit circle, the hypotenuse is what? 1. So if this is a 1, then you just have to figure out the x coordinate and y coordinate. That's right here and right here. So remember, 1 is equal to x square root 2 because you set 1 equal to the hypotenuse ratio. And you solve for the hypotenuse ratio as 1 over square root 2. And you rationalize it. That's equal to square root 2 over 2. And that's how you get square root 2 over 2. Hopefully you know this. Do you know this? If you don't know, if you know it, great. If you don't know, you better know it. So square root 2 over 2 and square root 2 over 2. Why? Because this part is square root 2 over 2, and this is square root 2 over 2. That is the height of the triangle. And this is the 45, 45, 90, and that's known to be that way. Got it? Okay. Am I going okay? Too fast? Too easy? You guys are like, for you guys asleep? All right. I don't want you to see you guys fail on the next test.
I'm not going to.
Okay, so the next one is the red triangle. So we're gonna use the red. So they don't have red. Let's use red. Okay, so what? Again, this is all the triangles, and this triangle is based on all the reference angle. What the hell just happened?
You made
Do
the
they-
wrong triangle.
Do they merge the color?
Yeah.
Here's the reference.
I drew it wrong anyway. That's okay, they can merge the color all they want. So this becomes 30, 60, 90 triangle. So that 30, 60, 90, again, go back to original geometry. If you have a 30, 60, 90, so that is going to be, well, if this is a 1, so according to the ratio, this is 2x, and this is x, and this is x times square root 3. That's the original ratio. You should know that this is on your SAT, and you will see it again. Okay, so now remember the hypotenuse that is equal to what? What is hypotenuse at unit circle? 1. So x is equal to 1/2. So that means the height is 1/2, and this is 1/2 times square root 3. So therefore, you see how wide this is? If you see this, how wide this red triangle is, this one's going to be square root 3. I'm going to use red. Square root 3 over 2, and this is 1/2. Are we okay here? And the square root 2 over square root 2, square root 2 over 2. And all rest of them just copycat. So it'd be square root 3 over 2, and then 1/2. And this is positive. So everything else is just kind of plus.
You got flip this too.
Oh, I gotta flip. This one is not flip. Yeah, sorry. Pi over 3. This is pi over 4. This is a 1/2. This is square root 3 over 2. So everything else is gonna be same thing and just copy plus minus. I'm not gonna go over the rest of that. I'm assuming that you guys already know. You guys probably already bored already. So we're gonna go into the identities. You guys on BC, so BC you need to know all the way to all the identity here. Every single identity you need to know. Probably something that you're not gonna use too often is some indifference. But double angle, power reducing, all this take account to everything. So now what happened is this is gonna be 1 over what? Cosecant theta, and this is 1 over what? Good. And then this is 1 over what? Okay, so this is 1 over sine. 1 over what? 1 over what? Okay, hopefully I don't need to talk about this. Tangent can be also sine theta over cosine theta. And this can be cosine theta over sine theta. And that's just a very standard. Again, the way I want you to know for triangle is knowing from the basic triangle, because we're going to talk about basic triangle a lot. And this is going to be A, B, C. So we know in geometry is a squared plus b squared equal to c squared. That's Pythagorean. If you divide everything by c squared, so that's going to be b squared over c squared. That's c squared over c squared. That's equal to a over c squared plus b over c squared. That's equal to 1. So that becomes a new identity because this is the data. A is the opposite. So it's opposite over hypotenuse square plus plus the adjacent over hypotenuse square, and that's equal to 1. You got it so far?
Yeah.
And that becomes sine squared theta plus cosine squared theta equal to 1. So sine squared theta plus cosine squared theta is equal to 1. That's the first identity from geometry transformed to trigonometry. Now that is going to be standard. Do you need to know how to prove that? No. But for your future reference, if you know how to prove, it's good for a lot of other things. So a lot of other math class requires it. Now, for this part, it didn't prove to the other two identity that you need to know is you do the exact same thing. So if you know how to do it, you can do it from here. Sine squared theta plus cosine squared theta is equal to 1. So I can divide both sides by what? Sine square. Good. If I do sine square, actually I won't start with sine square, but that's fine. So that's 1 plus cotangent square theta is equal to secant, oh no, cosecant square theta. Cosecant square theta. Now remember how you write down the data? Like you want to write sine square theta like this. You never want to write sine theta square because they're not congruent to each other. One is theta square, one sine square theta, which is this is a correct way to write sine times sine. Not sine theta square. That's actually a bad way to write it. That's bad. Are you okay? So this becomes the first one. Cotangent square theta is equal to cosecant square theta. You guys should already know that. Now you're going to do the same thing. You're going to say 6 sine square theta plus cosine square theta is equal to 1. I want you to divide everything by cosine square theta. Then that's going to give you a 10 square theta plus 1 equal to secant square theta. So you just prove A, B, and C. Do you need to prove B and C? Yes. For my test, you have to be able to prove A, B, and C. Now A might not need to. A just look like that.
So we just need to know how to turn A and B and C.
Now this is the part that you guys start getting foggy here. Foggy. 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 Foggy.
You got it.
Yes, I passed elementary school spelling. For sine is also called SMS, and for cosine it's called CSO. So that's an acronym to help you remember. So SMS stand for sine. This stands for mixed group and the same sign. Do you guys remember this? SMS. So that's gonna be mixed group. So it'll be sine, cosine, cosine, sine. And this is gonna be the same sign, and this is just gonna be A, B, A, B. And there you go. That's your SMS. And same thing for the other one will be sine because the mixed group. So sine, cosine, cosine, sine, like this. A, B, A, B minus. You just finish your first one. Am I going too fast? CSO.
Can you re-explain that?
SMS. S for stand for sine, M stand for mixed group, that you mix sine and cosine mixed together. So you start with sine, cosine, and cosine sine. And just put A, B in there. And the last S is stand for same sign. So same sign is A plus B. So it's going to be plus there. Got it?
And will the test be like?
Yep. It's the same exact sheet.
Okay.
There's nothing different. This is not a test. This is only a quiz. The test is actually you had to solve equations. Okay, so cosine of A plus B. So what is cosine of A plus B? So it's cosine, same group. Now, since it's a cosine, you're going to start with the same group as cosine. So it'll be cosine, cosine, sine, sine. And then cosine, cosine, sine, sine. And that's A, B, A, B, A, B, A, B, plus, oh no, sorry, is negative. So this is a B, B is negative, positive. This is sine. A, sine, A. So that is the sum and difference. Now you're gonna say, wait, do I have to remember sine of 2 data? The things you don't have to memorize is sine of 2 data because it can get it from the information from prior. If you think about this, right? What if I just have to sine of theta plus theta, right? So theta plus theta is what? Well, it's 2 theta, right? Hopefully, x plus x equal to 2x. So therefore, it's going to be sine of theta, cosine of theta, plus cosine of theta, sine of theta. Now, since this are the same, so can I just revert the second one to become 2 sine theta, cosine theta? Now, you can choose to memorize it, or you can choose to understand it, how you get it from sine. Why have 2 people watching? Weird. What's it called? Stream snipe?
Say hi to your viewers.
It's what they call it?
It's like a donation.
I don't know. See, I know my lingo. I watch Hikaru too much. That's what happened. Hikaru. Chess player.
Oh.
I really think about stream on Twitch.
Yeah, you should stream on Twitch.
I'd subscribe.
Yeah, we can get some
What if you get
stuff.
rated?
School doesn't allow me. Trust me, I try already. All right. So the sine 2 data is equal to 2 sine data cosine data, and that just because coming from the other one. Actually, you can get the same thing for the other one. Just imagine that if it's a cosine of theta plus theta, right? And just use the second one here. So that's going to be cosine of theta times cosine of theta minus sine theta. So you just come out the first one. It's called cosine squared theta minus sine squared theta. So they are related. They related from the sum and difference. So this is from here, and this is from here. They're not coming from nowhere. They're actually coming from before. It's just assuming instead of A and B, just theta plus theta. Now, with this, I actually told you 2 different things. This is the one thing that is easy from convert sine squared to cosine squared. So put in mind the first Pythagorean identity is actually going to give you 1 minus sine or 1 minus cosine. 1 minus cosine squared theta. And cosine squared theta is equal to 1 minus sine squared theta. So those are the conversion. You can convert from sine squared to cosine squared. And you're going to do that here. So instead of cosine here, I'm going to replace that with 1 minus sine square and a minus sine square. So instead of this, just go directly, and this is using conversion to get here. Conversion is changing cosine to 1 minus sine square, and it was eventually 1 minus 2 sine square theta, and that's becoming to the second of double angle identity. And same thing the other way, so it'd be cosine square theta minus 1 minus cosine square theta. And the 2 negative sign becomes positive sign, so it'll be 2 cosine square theta minus 1. And this becomes the 3 different version of double angle. So far, are you guys lost? Charlie, okay? Now, power reducing. Now, in Cooper's class, probably talk about half angle. I don't talk about half angle because I don't think that's very used often. So I will talk about power reducing, however, because power reducing help you to do integral of sine square of theta. Those of you guys know that if you try to do integral of sine square of theta, there's no way you can do it because you cannot do u substitution. You cannot change into 1 minus cosine square. That's not able to do integral if you're really good at it. So there is a way to integral sine square theta, but it's due to you have to convert the second degree to the first degree. So it turns out that you already have that tool because cosine of 2 theta is here, cosine of 2 theta. So this is the double angle identity. And if you pay attention, if I just solve for sine square, like if I just solve for sine square, right? So let's look at this. Let's change that. Let's replace the cosine square and sine square. So that's going to be 1 minus cosine of 2 theta is equal to 2 sine square theta. Does that make sense? I just replace one side to the other side. I subtract it and subtract back. Do you guys see that? Okay, sorry. Let me do it one step at a time. It seems like you guys are lost. So it makes sense? Okay, so 1 minus 2 sine square theta is equal to cosine 2 theta. So first I moved the other side. So it will be 1 equal to cosine 2 theta plus 2 sine square theta. And I moved cosine 2 theta to this side. So it'll be 1 minus cosine 2 theta equal to 2 sine square theta. And then I can divide it by 2 on both sides. So that becomes 1 minus cosine 2 theta over 2. And that becomes the first power reducing. The second one, you're going to do the same thing, except the second one is easier because you just move the 1 to the other side. You just have to move this 1 to the other side. So it'll be actually 1 plus cosine 2 theta over 2. And this is very good somewhere later that we can do this. And I will actually show you how to do it here. That's just going to be integration of 1 minus cosine 2 theta over 2. And you can split them. So 1/2 minus 1/2 integration cosine 2 theta. And then you need to use u substitution for this. U equal to 2 theta, and you go ahead and solve for it. So that is going to give me the first one and second one. There we go. Huh? How do I got B? I take this. I move the 1 over to right side. So it'll be 1 plus cosine 2 theta. And I'll divide by 2 on both sides. That becomes cosine square theta. Because this side is cosine square theta, right? You're pretty much just isolated cosine square theta. What? Is it? Holy shit. It's raining. We just talk about integral is what happened in BC Calc. You got to be able to integrate sine square. So, and then you can do that. You can u equal to cosine 2 theta. U equal to 2 theta. And u equal to 2 theta. And then you can simplify there. Yes.
You don't need to know this for the quiz or test, right?
No, you don't need to know how to integral something. Right now we stick with trig. Hopefully you pass this time. But I mean, I'm not gonna have a problem with you. You only miss on one small part. I don't think you check extraneous solution. Charlie did though.
Yeah.
On the radical. Yeah, he didn't do it though. You did. You're the only person did of the whole class. All the students. Okay, so any questions here? So there we go. Let's trig. Okay, let's talk about trig. You guys should know all the things. You guys should know what is tangent of negative 5 pi over 6. On top of your head, you got 30 seconds. Go. Tangent of negative 5 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. It's take too long already. You still don't know?
I got it. Root 3 over 3. Boy.
Root 3 over 3? Positive, because they're both negative. Root 3 over 3. You got it? Okay. What is secant of 3 pi over 4? Anybody want to have staring contest with me?
Negative. Oh, wait, no. No. Sorry. Negative root.
So first of all, how do I get this first one? I'm worried about it. Charlie, did you get this one or no? Tangent? Okay, so the best way to do this is I should just take a longer way and you will see it, start seeing it. So negative 6 pi over 6 and the cosine of negative 5 pi over 6 like this. And so this is the red triangle. If a 5 pi over 6 is the red triangle here, it has wider in length wider on girth, whereas the triangle is like a fatter, like fat triangle. Okay, and so the fat triangle should have the wider, so square root 3 over 2, but this is a negative, and this one should be negative 1/2 because if it's wider, it's going to be a little bit shorter, the triangle. So it'll be negative 1/2 times 2 over square root 3, and this cancel out, and that's going to give you 1 over square root 3, and you rationalize it, so that'd be square root 3 over 3. Is that okay here? Now for tangent, the best way to remember is this. The best way to remember is pi over 4. Tangent of pi over 4 is equal to 1 because that's easiest one to determine. Any pi over 4 is going to be 1 or negative 1. Is that okay? Anything pi over 6 is always going to give you square root 3 over 3. Anything pi over 3, tangent of pi over 3 is always going to give me square root 3. So just remember that sequence that pi over 6 is going to be square root 3 over 3, and that pi over 3 is going to be square root 3. It's going to save you a lot of time. Now here it's going to be 1 over cosine because you use a reciprocal identity. And that's equal to square root 2 over 2. Is that negative? Yeah, that's negative. So it'll be 2 over square root 2. And then you rationalize it. So it'll be negative square root 2. And that's my answer for this particular one. What? Yeah.
What was the top of the tangent?
Tangent of pi over 3 is square root 3. So you got square root 3 over 3, 1, and square root 3. If you know this value will help you for analyze where the tangent is.
What's the like?
If you want to know what you get on your test, come after school. We should be able to grade it by then. What?
It's only saying, well,
No, you cannot. Just come back after school.
Oh, okay.
Because I'll finish grading and all of them. So
because we both leave after 6. I go home and then be there for like 10 minutes. And then come back.
time to come in here.
I understand this part again. How to get that?
Okay, so remember, cosine 2 theta is equal to this, right? I'll do it this one here. So cosine 2 theta is equal to 2 cosine squared theta minus 1, right? So can I just move this to the other side? So it'll be 1 plus cosine 2 theta equal to 2 cosine squared theta divided by 2. Guess what? That's cosine squared theta equal to 1 plus cosine 2 theta over 2. Magic.
Also, could I see my on that school?
Like no one has ever.
Okay, fine.
Exactly.
So I was kind of confused. We have a quiz or a test this Thursday?
Quiz, I think it might be quiz and test.
Together?
Yeah, you're gonna have first part as a unit circle, and the second part is that, and the third part is solving the equation. So we'll go over how to solve the equation tomorrow.
Okay.
Do you have any worksheets or anything?
So we have a quiz and a test.
Can,
today.
like for homework tonight?
I'll post on them.
We have
Can I
homework?
see my test or no? Can I see my test?
We don't have homework.
You have homework.
Oh. What is the homework like?
I'll tell you guys in a second.
Good. I need homework. For your class. Can I see my test or that's a homework?
I'll come after school.
I can't wear shorts. I think I'll wear arm. Look at this side.
You have diabetes?
Huh?
You have diabetes?
Diabetes? No? Why do I have diabetes?
It's like my dad is like that. It's on the leg, and they just keep on scratching until it bleeds.
It's not. It's like I can pop. It's like I like
Acne. Then, yeah.
Maybe it is.